Welcome to the Actionable Futurist podcast, a show all about the near-term future with practical and actionable advice from a range of global experts to help you stay ahead of the curve. Every episode answers the question, what's the future of? With voices and opinions that need to be heard. Your host is international keynote speaker and actionable futurist Andrew Grill.
Today in the podcast, we're back talking about quantum computing. We last addressed this topic over a year ago on Series 4, Episode 22 with Richard Hopkins from IBM. Today, I'm delighted to welcome Chris Johnson, Senior Vice President and Global Head of Enterprise at Nokia. Welcome, Chris.
Thank you very much, Andrew. Great to be here.
Could you give us your definition of what quantum computing is and how it's different to normal or classical computing?
Imagine at a high level, a data crunching problem, a compute problem might take 1,000 years. Imagine that quantum computing might be able to do that in a day. So what we're talking about at a high level is a paradigm shift in crunching zeros and ones to crunching physical protons, neutrons, electrons, whatever you want to call them, but basically taking compute to multidimensional capability. This is just a monumental change in the way that we can crunch data going forward, would be my kind of high-level view, Andrew.
Now, I was asked a few weeks ago to address an audience and include quantum in there. I'm not a quantum expert, so I had to do some quick research. Quantum, you're saying, is a quantum shift, pun intended. What does it mean for business when quantum really comes into its own?
That's a good question. And I think the way we look at the world today in networking terms, right, and my background is obviously Nokia here, we talk about three kinds of network. We talk about mission-critical networks. These are sort of underpinning some of the kind of big infrastructure in society, energy, utilities, big transport networks, railways, public safety, police, defense, this kind of thing. The second type is what we might call business critical networks. This is where we've got enterprises, industries, healthcare, finance, just about any vertical you can think of, again, leveraging connectivity for their advantage. And the third category is social critical networks. This is really this human right to get access to the internet, to have a broadband network in your home. Now, quantum is going to have an impact in a couple of ways, right? One is that it's going to exponentially impact the amount of data that we're trying to network. And so from our perspective, we look at, the 2030 horizon, and we're probably talking 100-fold increase in the volume of data that's going to be shifting around networks. And quantum, of course, artificial intelligence and some other technological impacts are going to have a kind of a mixed impact, right, to create this 100-fold increase. And so number one, we're talking to the infrastructure guys, the business guys, and obviously social broadband network rollout folks to think about how they design and build in that context. But the second context is that quantum, probably in the 2030 timeframe, opens up a significant risk. So we're now transporting so much data that now can be unencrypted or deciphered or whatever by the raw compute power that's associated with quantum. And so we've got to start preparing now for that eventuality. To summarize, two impacts: a lot of data coming, ability of quantum to disrupt that. How can we take advantage of quantum, but at the same time, protect ourselves?
We'll talk about those risks in a minute, because I think they're things that people don't really think about because they're so far off. But you're right, if we're warehousing data right now, it can be unpacked and unfrozen later on. But let's just back up a bit. Nokia isn't a name I've heard linked with quantum before. So what's Nokia doing in this space, and what's been the journey to get here?
Connectivity is very central to some of these, kind of mission-critical national infrastructures, and it's very critical to the so-called Industry 4.0 movement in business, creating more productivity. And of course, broadband is rolling across the world. So we're very central in this world where the connectivity is being created. We can see the explosion, and we can see the impact of quantum or Q-Day, as it's sometimes called, rapidly coming. So what we're trying to do is create the quantum-ready ecosystem, quantum-safe network, really in Nokia terms. So looking at classical key distribution in networks, quantum keys, post-quantum ciphers. We're doing a lot of R&D in Bell Labs, and Bell Labs is fundamental to a lot of technological development in networking, but also in the quantum space for a couple of decades. What we're trying to do is understand, prepare our network to be quantum secure. And we've made our first moves with our optical networking technology, where we are working to integrate quantum key distribution capability in those networks. And in fact, there's a trial with Proximus in Belgium happening as we speak. We're trying to get very deep into the technology side, and we're supported by Bell Labs, but we're also now implementing real things in our deployable networks.
So you talk about Q-Day, and this is something I'm really interested in because in my research of quantum, let's just unpack what you said before. Right now, we use encrypted networks, we use VPNs, we have the padlock on our website when we're doing our banking. But what you're saying, if someone's actually recording even that encrypted traffic, there will be a day when someone can replay that and unencrypt it using quantum. Just maybe expand more on the risks there and how far away are from you. So you mentioned 2030, and that means, I suppose, it's imperative now to start building quantum safe networks. But is that really possible given quantum is going to be so powerful?
I think we know enough about quantum and its future capabilities. I think, where are we today with quantum? There's few instances, and there will be, this is incredibly fresh technology. It's expensive technology. It will be deployed in certain research centers initially, and it will become more available as costs come down over time, right? So this is where the 2030 comes from. By 2030, we think it will be prevalent and available to both those who can leverage it in a positive way and those who can use it for negative cyber purposes. So that's the context of 2030. It's just the availability of the technology. So what we've got to do then is anticipate the retrospective attack. And this is why Nokia takes a view that we've got to think about our networks and how we build them today, because they are going to be in place in 5 years' time. So I think you've got the retrospective view. How can we protect networks anticipating that people will have quantum at their fingertips? And then going forward, start to future check. Cybercrime is all about staying one step ahead, right? It's about anticipating. So we've got to take some anticipatory steps, and that's where Bell Labs will come in with sort of advanced research, we believe.
So we're still at the research stage. So it's not possible to produce quantum-proof encryption at the moment, or are we on the path to that?
We're looking across the portfolio. Number one, so our portfolio, Nokia, is very broad. From submarine cable to IP, optical, private wireless, mobile, radio network, large, small, data center networking. So we're very broad in our portfolio. So the start point has been the optical portfolio, where we're implementing a quantum key distribution technology, which is future-proofing the optical network. This is how we're running this live with Proximus as we speak. So there should be some publicly available kind of feedback on that. This is something that customers can launch today. Across the rest of the portfolio, we're taking a similar approach to protecting it retrospectively and then predicting the future possibilities.
Now, you and I know about the Q-Day threats that are out there because we're playing in this space. But do you believe that cybersecurity experts or even boards are even thinking about this at the moment? I mean, it seems a way off. And I suppose if you're on the board for 5 years, you don't really care if 20 years later all of your emails get exposed because they're probably going to be hacked anyway. What should companies do now? Should they be in exploratory stage? Is it just awareness, letting people know rather than frightening them? Because, I mean, at the moment, AI is the hot topic and everyone's saying, well, we're going to be replaced by robots. Is it fair to say that people are taking this threat seriously now?
I think it's an emerging consciousness, would be my transparent view. So I think we need to educate. It's our responsibility in the technology industry to educate the threat. I think there's a really, really high understanding and consciousness around cybersecurity today. It's probably one of the top technology topics that I think the CIO and the board would recognize. I think quantum takes this to another level. And I think this is where we've got to create an awareness, start educating about the 2030 kind of time frame, the possibilities. I think to just take responsibility as a technology industry for making sure that we're creating a future world now that does as much as possible to ward against it. So, this is kind of falls into the category of social responsibility, I think.
And podcasts like this is to raise awareness because my audience are senior business leaders and they're going to hear about this and go, oh, I need to ask my CISO about this. Are we aware of the quantum threat, the Q-Day threat? But let's look at the positive uses. So, okay, with negative use of quantum, let's assume we're in 2030. Quantum is around. It's available to most consumers and businesses. Give me some of the positive things that Nokia is working on when it comes to quantum.
Our approach to the world of enterprise. So you'll probably be aware of Nokia as a telco infrastructure provider. I run a part of the business that is focused on enterprise, pure and simple, and we've spent a lot of time looking at all of the vertical and really trying to work with transport, energy, public sector, but the industrial sectors, oil and gas, wind farms, renewables, healthcare, education, research, you name it, right? That we've been building quite a lot of subject matter expertise across all of these industries. And I think what we're noticing is this pattern to shift application processing to the edge of the network. So edge compute and edge processing becomes very prevalent. And I think that sort of then harmonizes with where quantum can come in. So we're going to be basically creating, I talked earlier about 100 times more data, and edge computing contributes to that. Quantum computing can then take that vast amount of data in the more centralized format and really take industry analysis to a new level. Think about industries, data-intensive industries today like finance, the volume of transactions, the complexity of transactions. Think about healthcare and particularly pharma. And a really good example might be new vaccines. We've been through the pandemic. There was a certain acceleration of the COVID viruses that gives an indication of how quantum processing can contribute to really speeding up the trialing process, which was almost reduced to 6 months. So research, clinical trials, seismic data, weather reporting and analysis. I think there's almost endless possibilities, but industry by industry, we're going to see specific high growth of data that can be analyzed at high speed to help businesses make intelligent decisions. Those that harness new technology the fastest are likely to be the ones that succeed in their industry. And I think artificial intelligence, quantum compute, of course, cloud compute, augmented reality, etc. These are all technologies that can be harnessed to give businesses advantage. And it's all about data. And quantum is no different. Quantum is just going to give us this enormous compute capability to speed up the journey.
More of my guests are talking about edge computing as something that's going to become a standard. And for, again, our global listeners, this is where you put the compute at the place where it's needed. A good example is, I think Vodafone were doing a trial up in Cambridge with Origo that run autonomous vehicles. And so some of the compute was actually at the 5G base station. It's important to have the compute where you need it. What I've seen from the research that my old employer IBM has done, a quantum computer these days is a large physical beast. It has to be cooled to minus 270 degrees Celsius so that the electrons move a lot faster. So that's not something that's going to be in a base station. We're going to see the interoperability of quantum and classical computing. So as you say, the heavy lifting is done by quantum. One thing I read about quantum is that it actually can really emulate the way nature thinks. And so you're right, with things like vaccines and deep financial problems, but maybe we could look at a couple of examples where edge and quantum work together and maybe they offload some of the computing power where it's needed. But quantum isn't going to replace classical computing, is it?
No, I don't think so, because clearly you've got, and the whole context of edge is that you can run applications that need the latency. For example, in a manufacturing plant, you have automated machinery, increasingly robotics, and the need to adapt those robotics to the environment in milliseconds. Clearly, the software and the applications that are running there are in real time, and they require classic compute kind of power. This is the edge compute paradigm. Of course, we create fundamentally huge amounts of data that can be hosted in the cloud, centralized. The latency is less, but really looking at the analytics at the big batch, what used to be called batch processing side of things, the ability to crunch huge volumes of, for example, financial data, healthcare data, clinical trial data, seismic data. We can sort of start to visualize possibilities. I think this is what quantum brings to us. It brings the art of data crunching to a completely new level that allows decision-making to be made much more rapidly. We've got customers with hundreds of sites. In, for example, the chemical processing industry, how can we be crunching huge amounts of data to optimize across not just a single physical location, but to start to apply machine learning and learnings from deep data analysis into multiple sites simultaneously. So, I think there's endless possibilities, many of which, of course, we can't even contextualize yet.
We've touched on the word AI a couple of times. I think contractually we have to mention AI in any podcast these days. You're head of enterprise globally. What sort of questions are customers talking to you about in terms of their aspirations for AI, and where does that manifest itself in the quantum world?
A huge and very broad subject. AI really appears everywhere from my perspective, from managing networks in the Nokia world. My daughter actually works for an energy utility, and they implemented AI to replace call center operatives to increase customer satisfaction. And it works, and redeploy those human beings to do other tasks. So AI is going to be and is starting to be prevalent in just about everything. I think that starts to drive rapid, instantaneous decisions based on the knowledge that exists already. So where does that dovetail with quantum? Quantum is going to be creating the intelligence that AI can take advantage from.
So in terms of preparing for a quantum world, what should and what are clients doing right now, other than talking to you and seeing what's coming next? What can they do to prepare in terms of the way they structure their data, in the way that they hire, the way that they train people? What do they do to prepare for this quantum world?
As new infrastructure is built, there has to be a built-in awareness of this context coming. In a Nokia customer world, there's a new network to be deployed or a new network strategy to be deployed, then quantum needs to be a part of the thought process of designing that network. And certainly we, as a vendor, as a technology creator, are helping our customers to build that into the RFP process, the tendering supply process. That needs to be in there, some simple acknowledgement of the existence of quantum threat in the future, and then things that can be done as the design process happens today. And this sort of, to me, almost falls alongside the sort of sustainability topic, the ESG topic. And I revert back to my point at the beginning about mission critical networks, the deep technology that sort of underpins society. We have got to make this future-proof. And so whether it's government or industry, I think we, again, have to take a social responsibility to almost implant these into any future networking requirements to make sure that companies are asking the right questions of vendors and technology experts. We've just got to really socialize this. And you're right, this kind of conversation we're having is part of that journey. But I think that the most important thing that we can do as a technology provider now is make sure that this stuff starts appearing in RFPs.
Are we close to the point where we'll actually see stickers or labels that'll say, this network, this software, this infrastructure is quantum ready?
I think this is inevitable, coming through real implementations of the like of Proximus that we're running at the moment with our optical networks. Yes, I think we've got to start branding in the same way that ESG needs to be prominent. We need to understand who are the companies that are supporting the journey and those that are not. You say there needs to be a kind of bumper sticker on everything. I tend to agree.
And AI is now so much in the talk track for regulators and governments. Should quantum and the Q-Day threat be something that governments are talking about, or is it too early, or are they seeing it's too far away to really worry about?
I don't think it's ever too early. I think the AI one is slightly more advanced, I think, as we're all aware. I think learning from that, we should start early on quantum. There's going to be huge positive societal impacts of quantum, but let's just make sure we're now preparing. Andrew, sometimes you can look back. We had the whole Y2K. I don't know whether you remember the Y2K. Some of the audience may remember. And that was probably quite a good example of really predictive thought process, the collective technology community really trying to mitigate risk well in advance. And I think this is, something we can look back on and learn from that and make sure that, we're creating the right level of consciousness.
I wonder whether we'll have people talking about the 1st of January 2030 being Q-Day and be preparing for it. I do remember Y2K very well. I was in Australia at the time, just before the millennium, and hoping all the lights would stay on when it hit midnight, and it did. That was certainly something that consumers were aware of, just as they're aware of AI. So getting this into the consumer mindset and into their thoughts and concerns is probably something that's going to push people to become quantum ready.
We've got to think about, at the end of the day, kind of advancement of technology. We've really got to be thinking about our energy grids, our water supply, our telecom supply, the fundamentals of our society, are vastly benefiting from technology. There's no question. But we also need to recognize the frailties and the weaknesses.
So last question before we go to the quickfire round. What are you most excited about when it comes to quantum computing?
I think it's the human advantage. I think it's what contribution this can have to healthcare, to simplifying, maybe demystifying the financial system. I think there's just endless possibilities to simplify our world for the benefit of everybody.
So my favorite part of the show, the quickfire round, we will learn a lot more about our guests. iPhone or Android?
iPhone.
Window or aisle?
Aisle.
In the room or in the metaverse?
In the room.
Your biggest hope for this year and next?
Happy family.
I wish that AI could do all of my
clothes washing.
The app you use most on your phone?
WhatsApp.
Best advice you've ever received?
Be authentic.
What are you reading at the moment?
Pink Floyd autobiography by Nick Mason.
How do you want to be remembered?
Authentic.
So as this is the Actionable Futurist podcast, what 3 actionable things should our audience do today to prepare for the threats and opportunities from quantum computing?
Be educated, read and understand, think about the possibilities. Number 2, let's be positive. And thirdly, let's protect ourselves, our customers, our families for the future by making sure that we're due diligent in what we do every day.
Chris, it's been a fascinating discussion. We're raising the awareness of quantum computing, its threats and opportunities, and this Q-Day threat. How can people find out more about you and your work?
Nokia.com, where we have a very big repertoire of technology information, but also how Nokia uses that technology in the world, across business, government, telecoms, infrastructure. And on LinkedIn. You'll see me on LinkedIn pretty regularly.
Chris, thanks so much for your time today.
Andrew, thanks for having me.
Thank you for listening to the Actionable Futurist podcast. You can find all of our previous shows at actionablefuturist.com. And if you like what you've heard on the show, please consider subscribing via your favourite podcast app so you never miss an episode. You can find out more about Andrew and how he helps corporates navigate a disruptive digital world with keynote speeches and C-suite workshops delivered in person or virtually at actionablefuturist.com. Until next time, this has been the Actionable Futurist Podcast.